Yeah. Yeah, good evening all. So myself, I'm Vijay. I hold like 17 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, I'll just going to cover the following topics, like what is big data? Yes. Why Hadoop? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, your screen is visible and the audio is clear.
Fine, thank you. So I'll be giving time for your general queries at the end of the session. Yes. And why Hadoop and drawbacks with the current databases as compared with Hadoop. Drawbacks with current databases. Hadoop advantages. Hadoop ecosystem components. Hadoop job market. Hadoop and Spark, right? Job market. Fine. What is big data? The name itself saying that big data, huge volumes of data, right? Huge volumes of data. So today, if we talk like how the data is getting stored, data storage units, right? You should have seen like KBs of data, MBs of data, GBs, or terabytes of data, TBs of data, petabytes, exabytes, zettabytes, yottabytes, sottabytes, so on, right? Yes. So from TB onwards, we say it as big data, huge data, right? So do you think like petabytes of data, is it getting generated in the current real world? If so, examples of petabytes of data generation, right? I want the sessions to be interactive, right? So you can unmute and you can just give your responses. Petabytes of data generation, are you able to see that petabytes of data generation? 1 petabyte equal to 1024 TB. 1 petabyte equal to 1024 TBs. That is already 1 TB is a large storage unit, but petabytes or exabytes of data, is it getting generated in the current world? If so, examples of it. Examples of petabytes of data generation. Yes. For example, if you take about any banking sector, right, like SBI or HDFC, if you take any bank like SBI, right? So within the city, you see hundreds of branches for a particular bank like SBI. Within the entire state, you see thousands of branches for it. Within the entire country, lakhs of branches for it. Again, within each branch, millions of customers, each customer making multiple transactions per hour, per day, per week, per month, and per year. Each and every transaction need to be stored, right? Huge transactions you are going to see, huge data. Forget about this. Everyone are aware about social media like Facebook, right? Facebook has got users not only within the country, within the entire world, right? Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What should be the storage capacity? What is the data generated by Facebook in a minute? Not in GBs or TBs, right? Petabytes of data generation. Not only like Facebook, right? Today, if you talk about any application generating huge data. If I talk about 1 minute transaction, if I talk in a minute, how many Facebook posts, FB posts? What is the data generated by Facebook in a minute? Twitter tweets. What is the data generated by Twitter in a minute? And everyone querying in the Google, right? What is the data generated by Google in a minute? YouTube videos upload, right? Everyone creating your own videos and uploading in the YouTube, right? What should be the storage capacity? YouTube videos upload. and millions and trillions of users using email or Gmail messages, right? So what should be the storage capacity for storing all these messages? Just now we're talking about bank transactions for thousands, for lakhs of branches, millions of customers making multiple transactions. Even for telecom transactions, right? And if you talk about like e-commerce websites, like e-commerce sites like Flipkart or Amazon, right? Generating huge data, right? And an average, they're generating like Google generating more than 800 petabytes per month on an average, right? Means 800 into 1024 TBs data generated at an average in a month, right? So how this data is getting, so we have got some databases for storing this data, right? We have got databases for storing this data. Databases like Oracle, MySQL, DB2, SQL Server, DB2, right? These databases, they are used for OLTP, online transactional processing for day-to-day operations, right? These databases can handle data up to some extent, but we have got some specialized databases. Right? Like Teradata, Netija, Vertica. So these are used for data warehouse purposes, OLAP, DWH, right? Data warehouse purpose. But these databases or specialized databases, they can handle data up to some extent, but beyond that, they cannot handle the data, right? So for that, as a storage level problems, and not only storing that huge data, processing that huge data, we need to have some proper tools for storing and processing it. So we got a framework like Hadoop, right? Which can store huge data and which can process huge data. But later I discuss what are the services provided by Hadoop. But before that, let me discuss like how this data generation happening. What are the different types of data and sources of data, right? Yes. So if I say like this is the entire data in the current real world, if this is the data in the entire current real world, which got generated from the last 50 years, from 1970 to 2022, right? If you observe this data, this is the entire data you see in the current world. But if you see, observe this is 20%, this is 80%, means 1972 like 2012 or 2002, right? Last 40 years, only 20% of the data from the last 10 years, especially nearly 80% of the data, whatever we see, right, is got generated from the last 10 to 15 years, right? Maximum data, right? But previously, if we talk in 1990s, right? So the storage systems you see, right? We have got floppy disks, just 1.44 MB of size, just not even 2 MB, 1.44 MB for the secondary storage systems. Later you got CD, compact disc, DVDs, right? What are the, see here, 80% of the data has got generated from the last 10 to 15 years as compared from the previous 40 years. Reasons for huge data generation. What are the reasons for the huge data generation, especially from the last 10 years? Because of usage of technology, because usage of internet and usage of smartphones, right? Because of usage of today, everyone using internet, today everyone using smartphones, and the usage of technology, right? Huge data is getting generated, right? The data which got generated, right, mainly it's of three sources. It's mainly of three sources of data. The data which got generated, right, mainly it is from the three sources, right? First, mainly like social data, right? Second, like machine data and transactional data. If you talk like a social data, right? Data which got generated from the social website like Facebook, Twitter, WhatsApp, all this, right? Such kind of data we call it as social data. Machine data means the data which got generated from reading or scanning the barcodes and RFID chips, right? Whenever you go to any shopping mall for the items you purchased, right? A bill is generated, right? Means the data which got generated by reading or scanning that barcodes, RFID chips, such kind of data we call it as machine data. Transactional data, day-to-day operations like bank. Talk about day-to-day operations like bank transactions, telecom transactions, right? And if I talk that this data whichever got generated, right, from the last 10 years, huge data, mainly occupying three types, right? Going to occupy three types. It's going to take three formats, three types of data. Structured data, you can say like structured data, right? Semi-structured data, and unstructured data. Unstructured data, the biggest challenge today, like most of the data, like 80% of the data, whatever is generated, it's mostly in occupying unstructured format. It's going to occupy like unstructured format, right? So storing that unstructured data and processing that unstructured data is the biggest challenge. Means if you take databases, they cannot handle unstructured or semi-structured data. They can handle only structured data. Structured data means which is arranged in the form of rows and columns, which are organized in the form of rows and columns, like Excel sheets, DB tables, and semi-structured, right? Like XML files, JSON files, which are not fully structured, which are not fully unstructured, right? Unstructured, right? Like short messages, articles, images, videos, all comes as unstructured, right? So day by day, as the data is increasing enormously, we need to have proper storage systems. We need to have proper storage systems for storing this huge data and for processing this huge data, right? So as a solution to all these storage level problems, right, we have got a framework called Hadoop. We have got a framework called Hadoop, right, for storing unlimited data, huge data, and for processing that huge data in quick time, right? Hadoop is meant for two things. It is meant for storage. It's meant for processing. Storage and processing, right? Yes. Observe here, we have got the technologies. Any technology, if we take like C or C++ or Java or .NET, anything, they are meant for, these are meant for processing. We take like Oracle, DB2, SQL Server, MySQL, right? They are meant for storage. If you take any technology, it is either meant for storage or it is meant for either processing, either storage or processing. So, but Hadoop is for both storage and processing. Hadoop is meant for both storage and processing. It performs storage and also it performs processing. That too, unlimited data storage, right? And that huge data we need to process in a quick time, so that we're expecting the results in quick time. So the processing should happen in quick time, right? Huge data processing, right? So Hadoop is a technology which is meant for both storing and processing, huge storage and huge data processing. You may get one query, right? If Hadoop able to store and process, what is the necessity of this processing and the storage technologies, right? When it is able to store huge data, it is able to process the huge data. Do you think like when Hadoop in the market, do you think these technologies like storage and processing will be away from the market? You need to understand what Hadoop is able to perform. So Hadoop is for not for OLTP processing, not for online processing, not for day-to-day activities, not for online transactional processing. It is for batch processing. Hadoop is for Batch processing, huge data means like millions and trillions of records. For that you go for Hadoop, not for example, a single transaction. You can go for this databases only, right? For one transaction or two transactions, no need of Hadoop. Hadoop is for millions and trillions of transactions. Hadoop is good for huge data. Hadoop is bad for small data. So here Hadoop able to store the data. Does Hadoop use any database internally? For storing the data, does Hadoop use any database internally? No. I'm saying like the databases has got some drawbacks. So I'll be just briefing you about the databases drawbacks. Despite of this drawback, still we don't go with databases for storing the data. So we go with a file system. We go with a file system called as Hadoop distributed file system. Later I'll be briefing you about this Hadoop distributed file system in brief, but Hadoop doesn't use any database. It goes with a file system called as Hadoop distributed file system. And for processing, right, Hadoop goes with a execution model called as MapReduce. It goes with an execution model called as MapReduce. Like, so today, like MapReduce, or currently we are using Spark, right? Spark for processing. MapReduce and Spark mostly used for very high speed processing, right? So Hadoop able to store the data and process the data. Two services given by Hadoop: storage and processing. So if you take the huge data generation, if you take big data as a problem, right? So you can say like Hadoop as the solution, right? If you take like big data as a concept, if you take, we can say like Hadoop as the implementation. Fine. And you may get a query, why databases can't be used? Why databases like Oracle can't be used for storing Hadoop data? What are the drawbacks with the databases? So drawbacks with the current databases as compared with Hadoop only, I'm saying, right? Drawbacks with the databases. So mainly the drawback, one by one I'll be listing out. Mainly like limited storage only. Unlimited data storage is not possible. Limited storage in GBs or in TBs, right? But higher than that, like petabytes or exabytes of data can't be supported by these current databases. And most of the databases, no parallel processing, right? Yes, most of the databases. And that if volume or the size, volume increases, right? The speed decreases, I'm saying. Speed is going to decrease. For example for this, I'll just, if I take a query, database query, right? Yes, observe this, select the total amount, sum of amount, select the sum of amount from sales one. Yes, select the total amount from sales one. Select total amount from sales two. Total sum of amount from sales one, select sum of amount from sales two, select sum of amount from sales three. Three tables, sum sales one, sales two, and sales three. Total amount from sales one, total amount from sales two, total amount from sales three. Think that sales one has got 10 records. Sales two has got 1 lakh records. Or sales three has got 1 crore records. Which query is going to execute faster among these three? Which query executes faster among these three, right? Total amount of sales one, total amount from sales two, or sales three. Obviously, the first query executes faster compared with the second and third, right? So query to query, as volume increases, speed is decreasing, right? Observe this. Next, like if complexity increases, right? Complexity increases, speed decreases, right? In the case of databases. Okay. I'll take the same query, right? Sum of amount from sales one. Just observe if complexity increasing. If I take a if you take a labor example, right? If volume increases, speed decreases. Even if you take a labor example, if a person carrying 5 kgs, he can run with that, right? If a person carrying 10 kg, if you increase the volume to 10 to 5 to 15 kgs, he can walk with that 15 kgs of that. But if that volume increases to 40 kgs, he cannot even move, right? Means if volume increases, speed decreasing there. Here also in the databases, if the records are increasing, that speed is decreasing. Complexity means, for example, sum of amount from sales one, I got some 1 lakh records. 1 lakh records, right? Select average amount I'm taking. Average amount from sales one. Same table from sales one. Same, it also got 1 lakh records. Select standard deviation of amount. Standard deviation of amount from sales one. Sum of amount from sales one. Average amount from sales one. Standard deviation of amount from sales one, right? Okay, which query is going to execute faster among these three? Yes, which query executes faster among these three? Total amount from the sales one, or average amount, or standard deviation of amount? See this second query, average amount. It's a two-step process, right? First sum need to be calculated, next average need to be calculated. As compared to the first query, second query takes more time. Standard deviation means lot of internal processing is required, means query to query, as the complexity increasing, speed decreasing, right? Yes. Okay. The major drawback, databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? They can handle only structured data. Fine. Observe. One example on this. If you take if you want to take reviews for a particular movie, right? Reviews for a particular movie. The table name itself is reviews, right? Just user or that review. Yeah, user one, right? User one, user two, user three, user four. In this way, 100 users giving the feedback. User one. Yes. User one, right? One is saying that one. User two saying the movie is bad. User three saying movie is good. User four saying that movie is bad, right? So just they are giving the feedback in the form of yes. Yeah, Kailas, I'll just come to your queries right at the end of this. Yes. User one saying one, two, ones and zeros, right? Their feedback is given in zeros and ones. One means good, zero means bad. 1 0 1 0 1 0, right? Zeros and ones. Yeah, just I want that Now, can you count using count aggregation? Can you count the number of ones and zeros and ones? How many people saying the movie is good? How many people saying the movie bad? Can you count using this SQL query that how many ones and how many zeros? Yeah, can anyone say the query? The table name is reviews. The column name, yeah, table name is reviews, right? Select
Select count reviews from reviews where review equals to 1, or
review
when
wise
we want.
count. Yeah, review
Yes,
wise
reviews.
count. Review wise count I want from the table reviews. Single grouping, single aggregation, right?
Yes, yes.
Review wise count I want from reviews table. Group by review means group by review means select output. Observe this output. Review wise count means for review means 1 and 0, right? 1 and 0. 1 0 count. 1 count is 90, 0 count is 10. Count review wise count I got from. You will group all that reviews of 1 and count on that. You will group all that reviews of 0 and count on that, right? You got this is the output. 90 people saying the movie good, 10 people saying the movie bad. But generally the feedback is not given, the reviews are not given in the form of zeros and ones, right? They give in their own text format. The first person saying that movie is good, second person saying that movie is not good. In this way their reviews are given in their own text format. Now can you write an SQL query for this? Can you count the number of goods and not goods? So this kind of data can't be handled by database. So even if you go for keyword count, it gives wrong computation, as even not good is having good within it, right? So it gives wrong computation. So these are the drawbacks, right? So as compared with Hadoop only, limited storage, no parallel processing, volume increases, speed, complexity increases, speed decreases, can handle only structured data. So okay, now coming to Hadoop advantages, right? Coming to the Hadoop advantages. To know Hadoop advantages, at least like minimum you need to know about the at least the overview of Hadoop architecture, right? So I'll come back to this Hadoop advantages. Just I'll take a minute or two to discuss Hadoop architecture. Like later I discuss in brief about this. Hadoop is not for client server. Hadoop doesn't follow client server architecture. It won't follow request response architecture. It won't follow. Right? Okay. Hadoop follows master slave architecture. It follows a master slave architecture. Single master, multiple slave architecture, right? It follows master slave architecture. Observe this diagram once. Master and slave. This is master. These are slaves. S1, S2, S3, so on up to SN, right? This we call it as slave nodes. Slave nodes. This is like master node. Master node, or in Hadoop terminology, we say like name node. This is slave nodes or data nodes, we say. Why the name data node? Why the name data node? Means in Hadoop, data is stored within the slave, data is processed within the slaves. Master node or name node, or slave node or data node, right? Yes. So in Hadoop, data is stored by the slaves, data is processed by the slaves. For example, in Hadoop, data is stored in the form of files. f1.txt file. Assume here each slave 1 TB of 1 TB, 1 TB, 1 TB, 1 TB, right? Yes. This f1.txt size is 2 TB. This 2 TB cannot fit into slave 1 or slave 2 or slave 3 or slave 4. They have 1 TB. So in Hadoop, the data will be distributed into smaller parts. Data is going to be it's going to be partitioned into smaller parts. Each part is going to be stored across multiple slave machines, multiple slaves. The data is going to be stored across multiple slaves. Okay. So here data is distributed across multiple slaves. Data is distributed across multiple slaves, and data is stored means 10 lakh records in this, 10 lakh records, 10 lakh records, 10 lakh records, 10 lakh records. Okay. Name node, right? Name node is responsible for that. Yes. Name how. So here 10 lakh records, 10 lakh records, it's stored across multiple slaves, right? Multiple slaves. Yes, sir. Chandrasekhar, in MongoDB, you have got a limitation. You can go up to like 500 slaves only, right? Rather than you can go maximum, 5,000. But we have got other data, other NoSQL databases like Cassandra is there, HBase is there, CouchDB is there, React is there, Peanut is there, right? We have got many other NoSQL, but there is a limitation for MongoDB. It can go up to 5,000 slaves for storing this. So here data is stored across two things you can observe, two advantages you can observe here. Data is distributed across multiple slaves and processed by multiple slaves parallelly. Your data, huge data object is divided into smaller parts, distributed across multiple slaves, processed parallelly. So very huge speed you can see, very high speed you can see, and unlimited data storage is possible here, right? So horizontally, Hadoop has got the feature horizontally unlimited scalability. Horizontally unlimited number of slaves can be added. Okay, later I discuss those properties, right? But here master node, name node, right? Yes. Observe. So these things you need to understand. So now coming to this Hadoop advantages. I'll discuss this architecture in brief, right? Storage architectural and processing architecture in brief, and the components in brief. So Hadoop advantages. Hadoop advantages. First one, unlimited data storage. Unlimited data storage. It's possible because there is a feature, because of a feature, right? Horizontally unlimited scalability. Unlimited scalability, right? Yes. Horizontally unlimited scalability is possible. Means horizontally unlimited number of slaves. For example, you're running a business with a number of slaves. For example, this is your master, you've got only less slaves, only 10 slaves. Your data is increased, your customers are increased, branches have increased, means your data also increased, right? So you cannot go with the same number of slaves as your customers, and customers increased by 1,000 times, data increased by 100 times, right? You cannot go with the same number of slaves. You will keep on increasing the slaves, right? Horizontally unlimited scalability. You can keep on adding, right? And second advantage, very high speed processing. Very high speed processing, right? Yes, Cloudera will be covered, right, Mohammed? Very high speed processing. Very high speed processing, right? Yes. Because of parallel processing. Because of what? Parallel processing. can handle all varieties of data, can handle all varieties of data. All varieties of data means structured, unstructured, and semi-structured kind of data, right? Can handle. And open source, it is an open source, no licensing required, right? Cost cutting, you can say. Open source. So very high speed processing because of parallel processing. I'll give a labor example. MapReduce is designed in such a way for parallel processing. It's a component designed for parallel processing. MapReduce performs parallel processing, right? Yes.
Sir, sir, I'm not able to understand who is consolidating the data and who is doing the parallel processing. Is Hadoop doing it or MapReduce doing it?
MapReduce. So here internally there is a process like job tracker, task trackers are available. Just observe this. So within this master node, we have got some processes like job tracker, task tracker 1, task tracker 2, task tracker 3, task tracker means job tracker is going to assign tasks T1 task to this, T2 task, T3 task, T4 task. Means this job tracker is responsible for the entire job. It divides the job into tasks, executing this 10 lakh records. For example, task 1, task 2, task 3, task 4. Assigning the task to the task trackers. Task trackers are responsible for executing the tasks. Task trackers, these are the processes within this, right? Data nodes available. So these task trackers executes the task, and job tracker is collects the final output, right? Job tracker is assigning the tasks and gets the job tracker is responsible. This I'll be discussing in the later architectural part, right? Storage processing components, storage components, and processing components. What are the work of storage components? How exactly their data stored and how exactly the data processed? Who is responsible for storing? Who is responsible for processing? How it is stored? Okay. How means internally we've got blocks. Data is divided into blocks B1, B2, B3. What is the default size of each block? And how these blocks are stored across the slaves? Those things, right? Fine. So coming back, right? It is very high speed processing because of parallel processing. Because of parallel processing, right? Yes. Observe. I give a labor example. Non-parallel and parallel, right? Non-parallel and parallel. If I take about a non-parallel, right? Yes, and parallel. For example, a one person preparing one item, taking 1 minute. The same one person preparing 10 items takes 10 minutes, right? The same one person preparing 100 items, taking 100 minutes, right? The same one person preparing 1,000 items takes 1,000 minutes. Okay. But here in the case of parallel processing, right? One item, 1 minute only. 10 items, 1 minute only. 100 items, 1 minute. 1,000 items also 1 minute. Means here 10 persons preparing 10 items take 1 minute. 100 persons preparing 100 items takes 1 minute. Say in the case of here persons, but in our terminology, systems, right? Slaves. Fine. So Hadoop advantages mainly like unlimited data storage and very high speed processing and handling all varieties of data. And if I talk about this very high speed, right? Yes, you can just check this, the speed of Hadoop as compared with other databases, right? Yahoo has conducted a test, right? Set has conducted a test to check the speed of various databases. It has taken a table of 100 TB, consisting of 1024 columns. The task sorting based on 16 columns, sorting based on 16 columns, right? Yes, what is the time taken? Time taken, right? Time taken by various databases, right? First, Oracle. It has taken nearly 3.5 days to process it, right? 3.5 days. MySQL. It has taken nearly 6 days. But we have got specialized databases like Teradata, which can handle TBs of data, right? We have got a Teradata, which can handle TBs of data. It has just taken 4.5 hours. Netija, another specialized database. Netija. It has just taken 3 hours. And finally, like Hadoop, right? Hadoop. It has just taken 3.4 minutes. 3.4 minutes for processing it, right? It has just taken 3.4 minutes. The latest version of Hadoop has just taken 1.2 minutes to process it. This is what the speed of Hadoop as compared with the other things, right? So the Hadoop has got a high speed, huge data storage. Today, if we talk like data, you're getting huge data everywhere. You see like huge data getting generated for storing it and for to process it, right? We are expecting the results. The industry is expecting the results in quick time. So we are going with processing tools like Hadoop, right? Which can process the data in quick time. Okay. So like we have got especially from ETL kinds of projects, right, are getting migrated, right, towards Hadoop environment. Wherever you see huge data migrating towards Hadoop environment. And even Spark is a in-memory computation. In-memory computation means within the memory level storage happening, memory level processing is happening. Very high speed you are going to see in Spark, right? Data storage and processing, everything happens at the RAM level. Let's be in. Yes, right. So just I was briefing you about what is big data, why Hadoop, right? Drawbacks with the current databases, Hadoop advantages, right? Hadoop ecosystems means the demo I'll be taking for today and tomorrow, right? 2 days you can just check. I need to discuss about the various Hadoop ecosystem components, right? And if we talk about this Hadoop job market today, if you can just Google and check the Hadoop and Spark jobs, right? If you see the salary packages for that Hadoop and Spark as compared with other technologies, you see like 1.5 times more than the other technologies, right? So at the same time, they'll be expecting the command in this, right, technology, right? So we'll be discussing everything from that ground level to the advanced level, right? From the scratch to everything. I'll be typing and showing you all these things. We'll be taking some bigger data sets, how we are going to store and how we are going to process it by using many processing technologies, processing tools, like and kind of data warehouse kind of environment within the Hadoop framework, using Hive, how to perform querying, how to create tables, and how to perform querying on the data, how to make the data structured and storing the data in the form of tables, Hive tables, and just querying on it, right? So as part of this course, I'll be discussing, right, Hadoop components and also like Spark in brief, in depth, right? And before the Spark, I'll be briefing you about like nearly like 2 weeks to 3 weeks. I'll be discussing on Scala, programming language like Scala, right? Yes, just observe this course content, right? Yes. Hadoop and Spark with Scala, right? Yes. So here, what is big data? Why Hadoop, need for Hadoop, sources and types, right? Storage and processing and databases versus Hadoop, advantages of Hadoop, Hadoop ecosystem, HDFS, like the storage system, right? Hadoop distributed file system. Their features, how this name node, data node, blocks, how to configure them, configuring block size and replications, HDFS architecture, name node, data node, job tracker, task tracker, how they are going to be performed, storage architecture, processing architecture in brief, right? Metadata management, storage and processing, replications, configuring custom replications, how to have our own block size, how to our custom replications, fault tolerance model in Hadoop, and various commands of HDFS, right? Hadoop distributed file system, and map reduce architecture, the processing domains, job tracker and the roles and responsibilities of it, task tracker, its roles and responsibilities, phases of map reduce, mapper phase, reducer phase, input split, right? And what is this driver code, mapper code, reducer code in this? Yes, I'll come back, right? Amit Patel, I'll come back to like, and next scoop, right? SQL plus Hadoop. First two characters of this and last three characters of this forms scoop, right? Means how you are going to get how you are going to pull the data towards Hadoop. Means how you are going to get the data ingestion tools. Means we are going to pull the data from different sources, different OLTPs. Means importing the data from databases to Hadoop. How to import and how to export after processing. I want to export the results back to the database. Importing and exporting of data using a component called scoop. So in this scoop, I'll be discussing in brief, right, of multiple imports. Means multiple, how to perform filtering during import, how to perform merging during import, how to perform grouping, and I want only specific columns, how to get specific rows, and how to perform various like merging vertically, horizontally if I want to match, and working with delimiters in how during this import, and similarly for exporting, right? Importing also from database to HDFS, from databases to Hive, databases to NoSQL database, from database to NoSQL. As part of the course, I'll be discussing a NoSQL database also, right? As a Hadoop developer, right, you need to have the knowledge about this framework like Hadoop, one NoSQL database, and even I'll be giving knowledge on streaming, right, like Flume and Kafka. So like exporting data from this, transformations and filterings, groupings, aggregations, incremental loading, incremental import, examples and operations, define how to define scoop jobs, and yarn, yet another resource negotiator, right? In the previous earlier versions of Hadoop, there were some drawbacks, right? Architectural issues. Everything got rectified from Hadoop 2 version onwards. We call it as yarn, yet another resource negotiator. What do you mean by speculative execution, speculative jobs, speculative task, comparison between the versions, comparison between the previous yarn architecture, it's various components, and also like that. I'll provide you the knowledge on a big Apache pig for processing, and my most concentration will be on the important component Hive. Hive is a component which is mostly used in any project, right? Right, it's a kind of data warehouse kind of environment. In Hadoop framework, we use a language called HQL. It will be similar to SQL. We are going to make the data structured and stored in the form of Hive tables, internal, external tables, partition, non-partition tables. We have got a performance tuning mechanism, improving the query performance using the partitioning, static partitioning, dynamic partitioning, and indexing, bucketing, right? And how to work with unstructured data, XML data, JSON data, URL weblog data, and performing unions, joins, and UDFs, UDTFs, right? Using this, and partition, non-partitioned, and coming to this NoSQL database. And in the Hive, performance tuning mechanism, bucketing, indexing, Hive and Hive HBase integration, right? A NoSQL database. What are the different NoSQL databases? Right, introduction to those, and HBase, one of the NoSQL database, HBase, right? Yes. HBase, total discussion on this HBase, how to perform CRUD operations, Hive and HBase integrations, HBase storage handlers, and HBase data modeling, the entire architecture of that. And coming to this Spark Scala. Apart from this, I said I'll be giving knowledge on streaming data and technologies, Flume and Kafka, right? Scala, first observe this. Spark and Scala, right? First, I'll go with Scala programming, Scala basics, data types, Scala variables, typecasting, Scala expressions, Scala control structures, Scala collections and transformations over these collections, right? Scala is the native language of Spark. Spark by default built by using Scala language, Scala functions. So nearly like more than 2 weeks, I'll be discussing a Scala before we go with Spark, right? Spark introduction to this, Spark comparison with any other technologies, right? And RTD computation, data objects, Spark data objects, we called as RTD, resilient distributed data sets. We say, what are those? What are the features? How it is getting computed? Steps in it. RTD persistence features, various ways of persisting, memory only, disk only, memory and disk only, right? Spark core computation, fault tolerance model, different ways of computing, creating Spark objects from Scala objects, increasing the number of partition, increasing, that is controlling the parallel processing, aggregations over structured data, reduce by key, group by key, reduce functions, groupings and aggregations, right? Different types of groupings, aggregations, process of group by key, reduce by key, various inbuilt transformations and actions, right? One by one transformation, like one by one count by key, all these transformations one by one in brief, transformations and actions. And also coming to this important like Spark SQL, the data frames concept. So Spark SQL, right? Yes. How to make the data structured, case classes, making the data structured, right? And using this SQL context, data frames, data frame APIs, and working with pure SQL statements, Spark and Hive integration with MySQL integration, working with CSV, JSON, and deployment modes, how to perform, right? In local mode, in clustered mode, standalone. And Spark application, what is stages and tasks, driver and executor, and how to submit Spark jobs, Spark Smurfit, creating jar file using Eclipse IDE, using Maven build tool, and using the simple build tool, right? SBT for creating an IntelliJ IDE. And I'm going to show you on two IDs, IntelliJ IDE and Eclipse IDE, and build tools like Maven and SBT, and how to launch the Spark applications, how to submit the Spark jobs, and also knowledge on Spark and Cassandra, right? So this is everything I'll be going to discuss in brief, right? Nearly 60 hours for Spark I'll be spending, like nearly 40 hours on Hadoop, totally 100 hours in brief, in depth I'll be discussing, right? Like 2.5 months I'll be taking, right, for this. For Sparks and Scala, like 1.5 month, and for Hadoop 1 month, total like 2.5 months combinedly, right? Okay, those who, yeah, prerequisites, some of them were asking that prerequisite, right? Everything before I start with the actual practical part, I'll be briefing you with the basic Linux commands. Just the basic Linux commands knowledge is enough. If it doesn't have knowledge, not a problem. I'll be giving the knowledge on these commands for 1 or 2 days. I'll be discussing all that Linux commands. Yes, and are you able to tell end-to-end pipeline? Yes, at the end I'll be showing that entire the pipeline, right? How this flow is going to happen. Cloudera, yes, it is going to be covered, and MapReduce is for parallel processing. Yes. So here previously the usage of Java was lot, right? But the usage of Java has reduced totally, right? We got like Spark with Scala. Most of the time we'll go with Scala programming, Spark with Scala. In Hive we got HQL language, Hive query language. In Pig we have got Pig Latin language. So previously we used to use a lot Java, but the usage of Java has decreased a lot, right? What will be the prerequisites? Show pass. Okay.
Hello, sir.
SQL queries and programming, will it be for me for continue for this? Yes, SQL basic knowledge required, but still you can go with this. We'll be discussing with many SQL queries, right? Duration of the course like 2.5 months. How will we practice means, yes, no, don't worry about the software. I will be providing the software, all the tools, right? To your Google Drives, right? You can just download it, and how I'll just demonstrate how to work on that software. You can just practice. I'll be so Hadoop can be easily be installed, right, with using VMware. I'll be giving the image to you and just work on this. All the components you can work on it, right? I created my own distribution, right? Yes, within that you can see all the components of Hadoop and Spark. Yes. So like Prasad, right? Will you do Hadoop and Spark? Yes, if you want to go Hadoop and Spark parallelly also. First, after 10 days of 10 to 15 days, right? We can go Hadoop and Spark parallelly. After
One
10,
batch is going on, right? Can we join that batch? 5 o'clock Spark batch is going on, right?
yeah, the basics of Spark completed in that. I'm starting Scala from tomorrow. In
You
that,
can join in that batch, right? If you want to. Huh?
yes, you can. Tomorrow I'm starting with Scala, right? You can go ahead with that. Scala programming I'm starting tomorrow, right? Introduction to Spark is there. You can, if you want.
Yes, sir. Hadoop parallel when it is.
Hadoop will be at 7 p.m. now. You'll be going with Hadoop 7 p.m. right? And if anybody wants to go with parallelly Scala also at 5 p.m. Scala tomorrow, Scala programming. For the next 2 weeks, I'll be discussing Scala programming, right? So by that Hadoop, the basic part will be discussed, covered, right? Like HDFS, scoop, those things. What all the things first required for Spark and Scala, I'll be discussing first in the Hadoop, right? So if anybody wants to go parallelly, can go parallelly. Tomorrow I'm going with Scala at 5 p.m. There is a batch started recently, 3 to 4 days back. Right. Tomorrow I'm going with Scala programming, right? You can just see the link in the website if you want to join for the scale. Duration of the course, 2.5 to maximum 2.5 to 3 months. How much classes on how many classes on each topics? Yes, see here, I said nearly 60 hours I'll be spending on Spark and Scala, right? Nearly 40 hours I'll be spending on Hadoop, right? HDFS, MapReduce, Scoop, Hive, and NoSQL database. You need to have the knowledge about NoSQL database. You need to have the knowledge about Hive, right? Environment and Scoop important, HDFS file system important, right? And also I'll give knowledge on streaming data and technologies, right? Spark streaming, micro batches, how to create the micro batches, right? Duration of the course will be 1 hour, right? Most of the students will be, they can spare only 1 hour. So duration of the course will be 1 hour daily, but sometimes on these weekends I'll be taking some session with okay, fine.
Hello, sir.
Yes.
Hello, sir. If we
Yeah.
compare big data Hadoop with development, sir, like Java and Angular, so what is the scope for big data, sir? Can you please tell me?
Java, using Java. So previously in 2014, 15, 16, right, 13, 14, 15, the usage of Java was huge in this Hadoop, right? At least, but once Spark has come, the usage of MapReduce has decreased a lot. Means totally, if I can say today, like MapReduce has totally, but MapReduce. Now we are going with Spark only maximum, or Hive. We are going with Hive, or going with Spark maximum.
Okay, sir. But
Java codings or Java program. Previously, only Java guys used to do this this Hadoop, right? But now anybody can update with it. So with Scala implementation or with HQL programming, right? Or with big Latin language.
okay, sir. I have 2 years of experience in Angular, sir. So my experience will be considered at the time of this interview will be scheduled.
So if you're already working in a company, already you are worked in a company, right? You can just by the end of this course, right? I'm taking 100 hours, like just go with 45 hours or 50 hours commercial aspects. So, but I'm spending these many hours. I'll be giving nearly 4+ years of much of knowledge I'm going to provide you. So with that experience, you can just add to your resume, and it doesn't mean that if you are good at your work with, right? They'll just check if you go for any background check also, they see whether they worked in the company or not, but in which If you are new, you can keep your experience in the Hadoop environment, right?
Okay, sir. Okay.
Fine.
So will
Okay.
you
So
be able to,
in diff,
will
so
you be able to take one
so
end-to-end
each and
pipeline, sir?
yes, definitely. At the end of the course, definitely I'll be showing you. And each and everything, each and every class, whatever I discussed, that will be clear to you. The sessions will be interactive sessions. I want response from your side. That means interactiveness from both the sides, right? All the sessions I'll be keeping you in unmuted status. Any queries there, immediately you'll be asking me. For each and every statement or whatever I do, right, you will be responding with the output. What will be the output for it, right? There's nothing theoretical, everything will be practical. I'll be showing you on this. So at the same time, whatever I perform, right, you will be doing it practically and checking it, right, for your better command on that particular component. The only thing is regularity is required, how regularly you attend, and working with, I'll be giving some assignments, tasks to work with, right, doing those things, and just spending 1 hour for the practicals daily, you can get the full command on this, right? And even for if anyone going for certification program also, I'll just give knowledge on that. Like,
Yes, sir. I have one question about certification, sir. So Databricks certification can I complete after doing this course?
yes, compulsory, right? So Cloudera CCA 175 certification, or see how that questions, how many number of questions, what is that time limit, the percentage, and how your performance is measured, right? Everything I'll be briefing you. I'll be taking a separate session on that. System requirements, yes. So don't worry about the system requirements. If you've got low system configuration also, I'll be giving multiple things, right? The images to work with your whatever system requirement. So the only thing is, if you've got good RAM capacity, 8 GB RAM like that, your speed will be good. If you've got lesser than that also, if you can extend it, you can extend. Otherwise, with 4 GB RAMs, how we can work on it, I'll be just briefing you, right, in our session.
Will you provide video also?
Yes, everyone, you will be getting every day you'll be getting the recorded session of that video. You can go through that video, you can analyze, and you can ask the queries at the next day at the start of the session itself. If you've got, first I'll going with the queries and later we'll go with the discussions, right? Yes.
Yeah, I have one question.
Yes.
Here.
Yes.
So we have Durga Software is having some other classes on Spark and Scala, right? So whatever they are covering in those classes, the same will be covering in this class, or anything less they will cover in this class, because the curriculum is like there are many topics here, right?
Yes. The thing is, the batch which is going on, I'm only taking it. So it is also a Hadoop and Spark batch only. The Spark has started, Hadoop completed.
Okay.
It's not, there is no specially Spark, right? Hadoop and Spark batches, because you need to have basic knowledge of Hadoop to go with Spark, right? So Hadoop has completed, Spark batch has started now.
So I just want to go for the Spark plus
yes.
Hadoop. So what you want me to do? Like, shall I?
You asked, right, the same content, whatever I discussed, right, the content is going to be same, right? The same content for all the Spark batches. There is no Spark. If you go with Hadoop and Spark, or only Spark, the same, right? Fine.
Okay. So shall I continue with the same these sessions?
Yes, you can go ahead with this Hadoop and Spark. Or if anybody wants to go parallelly, wants to decrease that time bound, right? So you can go parallelly also. If anybody wants to go, tomorrow I'm going with Scala programming, right?
Okay.
Okay, fine. You provide interview questions, sir?
Yeah, definitely. As part of our topics only, I'll be discussing a lot of things, right? What are the queries you will be getting? At the end also, I'll be giving some interview questions, related questions. Nearly some 30 to 40 interview questions I'll be saying at the last on different topics, mostly asked queries. And the roles and responsibilities, what do you do, everything I'll be briefing you, and some resumes I'll be forwarding you. You can just do it accordingly. Yeah, everything. Yes, Arnab, everything will be shown from the scratch. That's why I was typing and showing you. I didn't keep any PPT slides, right? Even in the demo session. I can keep all the PPTs, nothing, no PPTs, nothing. Everything I'll be typing and showing you how to open from the scratch. whatever topics, right? And even anything related to the basics also, I'll discuss that and I'll come. That's why I'm saying it's 100 hours, right?
Okay, thank you, sir.
Fine. Okay.
Will you
So,
show any like live projects which we can like coordinate or correlate the things?
yes, at the end I was saying like I'll be showing you the entire flow of a project. Yes. Kafka, yes, Arnav, right? Kafka I'll be showing you, right? Kafka and Flume Kafka, I'll be just giving you the knowledge on that. I don't know.
What about PySpark, sir?
So see, one thing, Spark is a execution model implemented in languages like Scala, Python, Java, or language. Observe Spark with Scala you can do, Spark with Python you can do, Spark with Java also, Spark with R language also. But Java and R language are very less preferred in the industry. Spark with Scala and Spark with Python both. But Spark, whatever is there, Spark APIs, everything remains same. Only the programming is going to change, right? Spark, how we define variables, how to define functions, collections, everything in Scala and Python. But Spark, whatever the Spark related things remain same. Yes, I am also taking PySpark classes in the weekends as of now. If anybody wants to go with PySpark, Spark with Python implementation, this is for Spark with Scala. Spark by default built by using Scala language. Spark by default written in Scala, right? It's a native language of Spark. Means Scala is only used for Spark environment, no other environment using Scala, right? So that's what total knowledge on Scala I'll be providing you. Then I'll go with Spark, right?
So I was also asking about the PySpark only.
Yes, PySpark. If you want to go for PySpark, right? There are separate batches, right?
Okay, when it is going to start?
Yes, you will be intimated, right? Already one PySpark batches is going at the weekend, right?
Okay.
So I'll let you know, right? If any PySpark batch is going to start, it will be started, right? Within next 2 weeks of time. PySpark.
Okay, yeah, okay. Thank you.
So nowadays everyone is looking for cloud only. What it matters with the will on this Hadoop Spark.
See one thing about the resources, everything you forget about it. But how exactly this processing, right? We are going to discuss like Spark processing, Hive processing, Pig processing, right? All this, how the processing, the same thing we are going to use, right? Fine. How this processing is going to happen means I want to get the results in quick time. What are the Spark related APIs? Everything we'll be discussing as what are the built-in transformations, what are the built-in actions you see, that we'll be discussing. Okay, fine. At the end, even if you want, I can show you in that cloud environment also. Fine. So still you people can attend the session tomorrow also at the same time, 7 p.m. with the same link to see more on this, right? How exactly the data storage processing, the other thing is going to happen, right? So if I'm done with your queries, if there are no other queries, then I will just sign off for today. Meet you tomorrow, same time with the same link, right? Thank you all for your time. Thank you.
Sir,
Yes.
sir. Sir, this Redshift and all these new cloud data warehouses, right? They are also based on Hadoop only, right? Meaning they say they need Scala programming and everything.
Yes.
They are on the same lines, right, sir?
Yeah, we have got many things right in cloud side also, but as of here we are going with this syllabus content, right? Those things what are discussed or not covered in this. We will be discussing this, whatever this big data Hadoop courses, that is components and Spark.
Okay.
The built-in.
Sir, are you taking any course on that also, sir? That cloud data warehouses also, meaning they are also distributed databases, right? Are you taking anything on that also, sir?
We didn't get much. We have kept batches on that. We didn't get much response. Everyone preferring for this only, right?
Okay. Okay. Sir, previously to that other question, right? That's what I was about to ask you. Like everybody these days, they talk about cloud data engineering, right? Like they also use this Hadoop and Spark and everything only. So do you think this going towards the cloud, sir? Or
Yeah. Towards means after within that also, what all these APIs are there, right? What all these Spark related things, what all these Hadoop Hive related things will be going to be the same, right? In that.
yeah, that's
So
right.
how
Yeah.
this processing, you'll be learning that here, right? About
Okay, sir.
about the resource, right?
Yeah, that's right. Okay, sir. Thank you.
Hi, sir.
Yes.
Question.
Yeah. Go ahead.
Yes. So basically, for the couple of years, we are seeing that as a data engineers are growing most. So the path of the data engineer, like when we are completing the courses, then after we are going to be completed the certification in the CCA 175 from the cloud era. Then after we are applying a job for that, then again we are getting it as a role of data engineer. Then after, how the path is going on, sir?
See, actually today, if we talk like mainly the data engineering work, okay, if you see like extract just like ETL kind of things you are performing, right? Capturing data, storing, querying, storing, sharing the data, right? So acquiring the data, summarizing the data, and so how we are going to pull the data, how we are going to pull, and how we are going to perform based on some applied business logic and processing it, how to process it, and once again you are going to export it to the, if the required sources, right? We'll be seeing here this.
So after completing of the data engineers, then we can move forward to the data analyst role.
Yes, compulsory, right? Data analysts, because after this only, right? Even if you talk a typical data scientist need to have the data about, that is the information knowledge about this, right? First this is going to happen, next after that you will be applying some ML algorithms and statistical analysis, right, on this data which is processed. Fine. So from this, even in Spark we have got library like Spark ML machine learning library, right? Spark supports this machine learning library. Because of that also Spark has got powerful. There was some other technology like a Flink available which was dominating Spark, but Spark came powerful with this ML machine learning libraries, right? So like Spark processing, and after that applying some ML techniques, machine learning techniques, and analyzing, right? So typical, as of now, the typical data scientist, they are dependent on this data engineers, right? And but in the future every data scientist need to have the knowledge about this big data, Hadoop, and Spark. So even if you go for data science courses, you will see a concept like Hadoop and Spark in that as a part of the course, right? Fine. But here yes,
Sir, some
yeah. Yeah, any more queries, right?
Could you
Yeah.
sir, will you please share?
Share pardon?
Hello.
Yes.
Will you please share the PDF of the syllabus, or it is the same on the website?
It is same on the website, right? Whatever is there in the website, the same thing. Again, you will be getting that to your mail also, right? Tomorrow.
hello, sir.
Yes.
Hello, sir.
Yes. Go ahead.
Sir, some of people are saying data engineering goes down, sir. I have read that statement on LinkedIn, sir. So what will be your statement on that, sir?
No. Actually, data engineering, no, not like that. Previously you got Informatica, all those, right? When Hadoop came into the market, you are not seeing that Informatica, that ETL tools. Previously they have got a great boom, right? ETLs. Now when Hadoop came, right? So this Hadoop has taken that storing and processing in quick time, right? So if you got any alternative, then you can say that. If you got any alternative, right? For the ETL, right? Extracting, transforming, and loading. But if anything comes into the market, also it should prove in the market. It takes time for that, at least 5 to 10 years. So if any technology comes to the market, immediately, like many POCs will be done on that. So see, Hadoop will be in the market. So you can see, just check in the Google, right? Hadoop and Spark jobs as of now.
Okay, sure.
Sir, is it possible to change the timing of the class? Because in my current project, we have daily Scrum calls from 7:30 to like 8:05 or 8:10. Is it possible? Hello, am I audible?
Yes, but 7 o'clock is the time. So if anybody, right, okay, fine. If unable to attend, you can just go through the video that day recording, right? If you've got queries, you can ask me at the next day. You are saying you can, yeah. There are many students who are doing jobs just following the videos, but I'm not recommending you that. But anyhow, for at least if you're offering half an hour, you can just go with your queries. But the time changing of time, no, 7 to
Okay, no,
seven
thank
to
you.
eight. Yes.
Good evening, sir. Just wanted to check with you. Like, is there, sir, any ping batch which would be morning shift?
No morning shift. No, as of now, there is no morning shift.
So all the classes will be in evening, sir, only.
Evening only. Yes.
Sir,
Oh, okay.
Yes.
sir, only request is, can you please keep the time as 7 p.m., sir? Because we have moved our Scrum and everything for this course, sir. So can you please keep it at 7 p.m.?
Yes, it will be 7 to 8 only.
Yeah, because sir, because for people outside US, it's like 9:30 a.m. for us. So we have moved all the Scrum to attend this course, sir.
Yes.
So yeah, because from my company, 3-4 people we are attending it together. So we have moved the Scrum for this course, sir.
Fine. It will be the same timing, right? Yes.
Yeah, thank you, sir.
So, okay. Later, right? Once you get enrolled into the course, once you get registered, right? Even there will be a group, WhatsApp group for the direct interaction with me, right? Any
Okay.
other questions?
Yeah, we have already registered for the course, sir.
This one
Yeah, we already registered, sir.
means enroll means by paying the fees.
Yeah, sir. Fees also we have sent it, sir.
Okay, fine. Whatever it is, yes. So later we'll be having a group, WhatsApp group for direct interaction, for the technical interactions, other things, right? Fine. So okay, fine. I'm running out of time. So if you've got any queries, you can go ahead. Tomorrow also you can ask your queries. Tomorrow we'll go at the same time, 7 o'clock with the same link, right? Okay. Thank you all for your time. Thank you. Meet you tomorrow. Fine.
Thanks, Vijay. Thank you all.
Thank you.
Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear? Yeah, can anyone please confirm that whether my voice is clear or not? Fine, thank you, and sorry for the delay. So in the last class, just I was briefing you about like Bigdata Hadoop, the services Hadoop, and drawbacks with the current databases, right? So here Hadoop databases like Oracle, MySQL, SQL Server, right? Used for OLTP, online transactional processing. And we've got some specialized databases, right? Teradata, Netezza, Vertica for data warehouse purposes, right? But we doesn't have a proper tool to store like huge data, right? Like terabytes or petabytes of data low. So as all the storage level problems, like, and all the processing levels, right? We have got a framework like Hadoop, right? We've got a framework like Hadoop. Hadoop is providing two services. Hadoop provides two services. Hadoop is meant for storage. Hadoop is meant for processing. Hadoop can perform both storage and processing, right? For storage, right? Store doesn't use any database for storing its data. It uses a special kind of file system called HDFS, right? Hadoop distributed file system. And for processing, it uses MapReduce, right? For processing, it is using MapReduce or Spark. Spark, right? Yes. For storage, it's using like HDFS, and for processing, MapReduce or Spark. Fine. So Hadoop is meant for batch processing. Hadoop is meant for batch application. Hadoop is meant for, observe here, right? Hadoop is meant for batch applications, right? Yes. Or for batch processing. It is meant for batch processing or for batch applications. It is not for online applications, right? It is not for online applications, right? Okay. There are two types of applications. Mainly, there are two types of applications. Online applications and batch applications. Batch applications. Online applications and batch application. Online application means user interactive applications. User interactive application. Here user gives the input, right? Here user gives the input. User interactive application. Here user gives the input. Example of online application, making an online transaction, right? Making a online transaction. Booking a movie ticket, for example, booking a movie ticket. Here user gives the input, right? Here. And batch applications means user non-interactive applications. We call it as batch applications. User non-interactive. User non-interactive applications. Here user is nowhere required. User is nowhere required, right? Yes. Here user gives the input. Here user is no way required. Example of batch application, right? For example, if you talk like railway ticketing PNR status. PNR status, right? Yes. For example, currently your status is 150, like after 1 hour, after half an hour, right? Like after 1 hour or 2 hours, it's like 100. Tomorrow, if you see like it is 50, or tomorrow evening it gets confirmed, right? It is happening in the background, right? Batch applications means background applications. They run in the background, right? Here they are non-interactive. Here user is nowhere required. Without the interference of the user, right? It's going to happen. Most of the financial sectors, right? The financial applications are batch applications without the user interference, right? Which has got more load, online applications or batch applications? Yes. Which has got more load, online or batch? Batch has got more load, right? Because for example, generating credit card statement for millions of customers, right? Batch, which has got more load means, this one, right? Batch has got more load. Generating credit card statement for millions of customers, or bank statement generation for millions of customers. Bank statement generations for millions of customers. So this has got more load, right? Online application, batch application. Batch applications, most of the applications like in financial sector, they are like batch applications, the user non-interactive applications. So Hadoop is meant for batch applications, not for online applications. And drawback with the current databases, right? Drawbacks with the current databases: limited storage, no parallel processing, And volume increases, speed decreases, and complexity increases, speed decreases, right? Yes, I was seeing an example, right? So query to query, if that volume increasing, speed decreasing, right? Yes. Complexity increases, speed decreases, right? Yes. Okay. Databases can handle only structured data. The major drawback, right? Databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data, right? Yes. Fine. Now, if I discuss about this, Hadoop follows master-slave architecture, single master and multiple slave, right? Yes. Hadoop follows single master and Hadoop master-slave architecture, right? What do you mean by Hadoop cluster? Cluster, right? Cluster, group of CPUs connected in a network. Group of CPUs. CPUs means nodes. Within the brackets, I'm saying that group of CPUs, nodes connected in a network. Connected in a network, right? Yes. There are two types of nodes. Two types of nodes, right? Two types of nodes. First one, master node, and second is what? Slave node. Master node and second is slave node. Master node or name node, right? Master node or name node. Slave node or data node. Just observe this, right? Yes. Hadoop follows the master slave, not Hadoop doesn't follow client server architecture. It follows master slave architecture, right? Single master and multiple slaves. This is master. This is slaves, multiple slaves. Single master and multiple slave architecture, right? Yes. S1, S2, S3. These are slaves. Data nodes, slaves are data nodes. We call it as master node or name node. S1, S2, S3, right? Slave nodes or data nodes, right? So in Hadoop, data is stored in the form of files, f1.txt. The files are divided into smaller parts. Files divided into smaller parts. Each part is stored across this multiple slaves and processed parallelly, right? So 10 lakh records in this, 10 lakh records in this, 10 lakh records in this, right? So data is divided into smaller parts. We call them as blocks. They are getting distributed across the slaves. Data is getting distributed across the slaves, and data is processed by multiple slaves parallelly. Data getting distributed across multiple slaves and data processed by multiple slaves parallelly, right? Yes. Fine. So what is the responsibility? Master node responsibility and slave node responsibilities here. Master node responsibilities, right? Master node responsibilities means, yes, task assignment. Task assignment means, so this master node assigns task T1 task to this slave 1, T2 task to slave 2, T3 task to slave 3, right? So 3 tasks are assigned to the 3 slaves and are executed parallelly, right? Parallel processing is going to happen. load balancing. Secondly, what is the task of this master node, right? Load balancing. Load balancing means the task or the load is going to get balanced among these all the slaves, right? So that the task need to be given equally to all the slaves. Fault tolerance. Fault tolerance means, so here if you observe this diagram, multiple tasks are executed by multiple slaves parallelly, right? Multiple tasks are executed by multiple slaves parallelly. So when multiple tasks are executed by multiple slaves, as these are machines, right? Suddenly, if any machine goes down, then the task of that particular slave will be reassigned to any of the available slave. This process we call it as fault tolerance mechanism, right? So here the task job won't be failed, right? So assigning when multiple tasks are executed by multiple slaves, then if any one slave goes down, then the task of that is assigned to any of the available slaves. This process. So we'll have a lot of discussion on this fault tolerance mechanism. I'll have a separate discussion on it. And health monitoring before you are assigning any task to the slave. So each and every slave health condition is known by the master node. Health monitoring, right? Yes. Slave node responsibilities, right? Yes. Slave node responsibilities, first one, like storing data. First one. Second is like processing data. Storing data and processing data, right? Master node responsibilities and slave node responsibilities. Okay. So next is Hadoop advantages. Hadoop advantages, right? Unlimited data storage because of horizontally unlimited scalability. Horizontally unlimited number of slaves can be added, right? Very high speed processing because of parallel processing. Horizontally unlimited scalability can handle all varieties of data. As I was showing you an example, processing point of. But before this, I got one more query, right? Why databases like Hadoop? Sorry, why databases like Oracle? Why databases like Oracle, right? Cannot support unlimited storage. Unlimited storage, right? Mass, why only Hadoop can perform it? Why not the database like Oracle cannot support unlimited storage? If we talk that in real time, if we talk about these databases like Oracle can go with multiple slaves. See these databases. Max limit on number of slaves. Databases and the max limit on number of slaves, right? Yes. Databases. Oracle database. Oracle max limit on the number of slaves means it can go with maximum 256 slaves. MySQL, right? Yes, MySQL. It can go with 54 slaves. MySQL with 54 slaves. MySQL Express can go with 256 slaves. 256 slaves, right? Yes. Can we create multiple master in Hadoop cluster? Yes, yes, we can have multiple masters from Hadoop. Yeah, Saikat Das, right? Yes, from Hadoop 2 version onwards, there is a concept called high availability. From Hadoop 2 version onwards, we call HEA. HEA means high availability, right? Multiple name nodes we can have. Name node 1 you can have, name node 2 you can have, name node 3 you can have, right? Multiple master nodes, name nodes we call, right? Name node 1, name node 2, name node 3. Yes, at a point of time only one name node will be active. See, observe here, name node 1 will be active, name node 2 will be in passive mode, right? Only one master will be in active, the remaining will be in passive mode. Name node 3 also will be in passive mode. So these passive name nodes will keep collecting data from active name node. This passive name nodes will keep collecting data from active name node. Suddenly, if active name node is down, then immediately any one of the passive name node will become active. Assume this is active, right? Yes, this will be in passive. And if this active name node is also down, right? When this active name node is also down, then immediately this will become active. So we can have multiple masters, multiple name nodes, but only one will be active at a point of time, right? If that goes down, immediately we can go with other name node, right? If that also down, we can go with multiple name nodes, right? Yes. See, observe here, right? In the diagram previously, if one slave is down, then we have got other slaves to process it. Slave, one more slave down, then the other slave can process it. Master node is down, then we can go with another master. And from Hadoop 2 version onwards, we have got multiple, a high availability, we say. We call it as HA, high availability. Fine. So I was just checking why databases like Oracle cannot support unlimited storage, because there is a limit on there. So Oracle can go with 256 nodes or slaves, MySQL Express, right? And DB2 also can go with maximum 256 nodes, 256 slaves or nodes, right? Yes. SQL server also, right? SQL server also can go with maximum, right? Can go maximum with 256 slaves, right? Okay. So any of this database can support maximum 56 slaves. These databases are used for OLTP, right? Online transactional processing, but none of these database supporting unlimited storage. If you talk about this Oracle, right? Even if 256 slaves given, even if that slaves are used, right? The performance of the system degrades, right? Just like if I take a labor example, if you take an example of your mobile phone, right? In your mobile phone, if you've got 64 GB of RAM, if you've got like 64 GB internal storage, if 64 GB internal storage given, if you are filling all the 64 GB, right, the performance of your phone degrades, right? It goes slowly. The same way, if 256 slaves given, if all the 256 slaves gets filled, the performance of the Oracle degrades. Sometimes it won't even start, right? But we have got some specialized databases, specialized database used for data warehouse purposes, like Teradata, right? So it can go with a maximum of 512 slaves, 512 slaves or nodes, right? Netija also it can go. It's a specialized database used for data warehouse purpose. Can also go with 512 slaves. 512 slaves or nodes, right? And Vertica, one more specialized database, right? They also can go with 512 slaves. But currently, this Teradata going with 1024 nodes or slaves. 1024 slaves for storing its data. Netija also, right? It is going with 1024 slaves for storing nodes, means for storing its data. But still, if you say like 1024 slaves, right? Still, it is not unlimited data storage, right? It's limited, right? It's unlimited. It's not unlimited data storage. None of these databases or specialized databases can handle huge data or unlimited data. They are limited to up to some extent, but beyond that, they cannot support the data further, right? Yes. But there is no limit. There is no limit on number of slaves, right? That Hadoop can. But there is no limit on number of slaves that Hadoop can have, right? Yes. There is no limit on the number of slaves that Hadoop can have. Unlimited. So horizontally unlimited scalability. Horizontally unlimited number of slaves can be added, right? So unlimited data storage is possible in Hadoop, right? There is no limitation. So there was some Yahoo when first time implemented Hadoop. When first time implemented Hadoop, right? Yahoo when first time implemented Hadoop went with 4,000 slaves for storing its data. 4,000 slaves for storing its data. Currently Yahoo going with, currently it is going with 12,000 slaves for storing its data. 12,000 slaves for storing its data, right? Yes. Currently it is going with, okay. Facebook, right? Facebook when first time implemented Hadoop. Facebook when first time implemented Hadoop, right? Facebook when first time implemented Hadoop went with 8,000 slaves for storing its data. 8,000 slaves or nodes for storing its data. Currently it is going with 36,000 slaves for storing its data, right? 36,000 slaves for storing its data, means nodes, CPUs for storing its data, right? Okay. So there is no limit on the number of slaves that Hadoop can have, right? It can go with any number of slaves, 1,000 or 5,000, 10,000. There is no limit on the number of slaves that Hadoop can have. So Hadoop is proven in the market, storage point of view, with unlimited number of slaves and unlimited data storage and very high speed processing. Yesterday I was discussing about this high speed processing point of view, right? Yes. Processing point of view, right? Yes. So Yahoo has performed a test to check the speed of various databases in the market, right? It has taken a table of 100 TB consisting of 1,024 columns. Task was sorting based on 16 columns. Task is sorting based on 16 columns, right? So time taken by the various databases, right? Oracle has taken 3.5 days to process it. MySQL has taken 6 days. Teradata has taken 4.5 hours, right? Netija has taken 3 hours to process it. Hadoop has just taken 3.4 minutes, right? Latest version of Hadoop has taken 1.2 minutes, right? This is what the processing speed, right? Processing speed of Hadoop. So Hadoop proven in the market, processing point of view and storage point of view. Storage point of view, unlimited number of slaves. Processing point of view, very high speed processing and parallel processing. That's what I was discussing here. Unlimited data storage because of horizontally unlimited scalability. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured kind of data. It's an open source, no licensing required, right? Yes. Okay. Hadoop ecosystem components. What are the components I'm going to discuss, right? Hadoop ecosystem components, right? Hadoop ecosystem components, what I'm going to discuss as part of this course. All right. HD, so we have got many storage and processing components available, right? We've got many storage and processing components. For storage, we have got like HDFS, right? HDFS. This is meant for storage, right? Hadoop distributed file system for storage. So I said like Hadoop doesn't use any databases. Databases has got some drawbacks, right? Despite of this drawbacks, still Hadoop doesn't go with the databases for storing its data. It goes with a special kind of file system called Hadoop distributed file system, right? One second. Yeah, HDFS meant for storage, and I got like MapReduce, right? MapReduce. It's a parallel execution model. It's a model execution model meant for parallel processing. That is meant for store processing, right? It's meant for processing. Apache Pig, right? Apache Pig. It is also meant for processing. It is also meant for processing, right? Yes. So we are using a language called Pig Latin language. It's a Pig Latin language, a simple scripting language, which looks very simple and easier, like 100 lines of Java code. The same task you can write in Pig with not less than 6 lines, right? That is what the easiness of Pig, Apache Pig. And Apache Hive, right? Yes. Hive is an important component in Hadoop, mostly used in various projects. So here it's a kind of data warehouse kind of environment. It is also meant for processing. It is also meant for processing. It is a kind of data warehouse kind of environment in the Hadoop framework, DWH. Here we use a language called HQL, which is similar to SQL, right? Yes. Hive query language, which is similar to SQL, right? Right here we will be creating, we are making the data structured, and we perform querying, right? Data, and we'll perform querying on that. We'll create internal tables, external tables, and partition table, non-partitioned tables. And scoop, SQOOP, right? Scoop, right? It's a combination of SQL and Hadoop. SQL plus Hadoop, right? Yes. The first 2 characters of this and last 3 characters of this form scoop, right? Yes. So it is for import or export operation, for importing data, bringing data into Hadoop environment from different data sources. And also after processing, you are just going to export the data to different other data sources, right? Yes. Import or export operations, right? It's a data ingestion tool. And NoSQL, right? NoSQL database. We have got many NoSQL databases, right? HBase, Cassandra, MongoDB, CouchDB, React, Peanut, Neo4j. Yeah, just 1 second. Let's do that. NoSQL database. We have got many NoSQL databases. One of that, like we have got like HBase, Cassandra, MongoDB are the famous NoSQL databases. Apart from this, we have got many other databases like NoSQL databases like React, Peanut, CouchDB, Neo4j, right? Here, NoSQL means schemaless behavior. This schemaless behavior, right? Schemaless behavior, right? Yes. Means in SQL, compulsory schema required, right? First record to last record, same number of columns need to be maintained. We need to specify the columns and their data types. But here, in the case of NoSQL, record to record, different number of fields can be maintained. My first record with 3 fields, second record with 5 fields, third record with 7 fields, right? Record to record, different number of fields can be schemaless behavior. You can see in NoSQL. Random access, right? How to perform sequential access, but randomly if you want to go, right, you go for NoSQL database. So how to perform batch processing? NoSQL can perform like online processing. Combinedly, both can perform both, right? Batch processing and online processing. So as a Hadoop developer, you need to know at least one NoSQL database. As part of the course, we'll be discussing one NoSQL database like HBase, right? HBase is a kind of NoSQL database which is especially designed for a Hadoop environment only. But if you talk about Cassandra, MongoDB for open applications, but not only for Hadoop applications, for other applications also, right? And apart from this, Yarn, yet another resource negotiator, right? Yet another resource negotiator. So from Hadoop 2 version onwards, there were some architectural changes. So one by one, I'll be discussing the differences between the previous Hadoop versions and these versions, and the Yarn components, the other things, right? And Zookeeper controls and coordinates all the other components, right? For connection establishment, other things, we use this component, right? And streaming data and technologies, Flume, Kafka, right? Just I'll be giving knowledge on this Flume and Kafka. So these are streaming data, and Flume is for streaming data. Kafka is for advanced streaming data, and also for messaging also we use Kafka, right? Streaming data. What do you mean by streaming data? Means streaming data which keeps on generating, data which keeps on incrementing. Such kind of data we call it as streaming data, which keeps on generating, which keeps on incrementing. Like such data we call it as streaming data. Okay. Next, like Spark, I'll be discussing about Spark, right? Next important component, Spark, right? Spark using Scala language. First, I'll be discussing about using Scala language. Total entire Scala fundamentals, Scala data types, Scala variables, Scala control structures, Scala collection, Scala functions, Scala everything about Scala programming. I'll be discussing for more than 2 weeks, right? Because total programming goes in Scala. Next, coming to the Spark core programming. Spark core programming, where we see like RTD's concept, Spark data objects, their computations, how this Spark data objects are computed, and various inbuilt transformations, and inbuilt actions one by one. And later, like I'll go with Spark core programming, Spark SQL, right? Next, Spark SQL, where we see that concept of data frames, data frame APIs, how to make the data structured and create data frames, and performing various data frame APIs, and also working with pure SQL statements, making the data structured and working with pure SQL statements, right? Creating temp tables, temporary tables, and working on it. And also I'll be giving knowledge on streaming, Spark streaming, creating micro batches, Spark streaming, like creating micro batches, DS streams, right? So Scala programming, Spark core, Spark SQL, and Spark streaming. And nearly like writing and how to create job files and how to submit Spark jobs. I'm going to show you on Eclipse IDE, IntelliJ IDE, and using Maven build tool, SBT build tool, right? And so for this Spark core, Spark Scala, Spark core, and Spark SQL, Spark streaming, right? Nearly I'll be taking like 60 hours of classes, right, for this. And for this Hadoop, I'll be taking nearly 40 hours, totally 100 hours of course, right? So nearly I'll be taking like in brief, in depth, right? Actually, for 2.5 to 3 months it takes. 2.5 months I'll be taking for this. And deep in brief, in depth, I'll be discussing about all these 11 components, right? In brief, mostly in Spark, more concentration on Spark, Scoop, Hive, the important components like Hive, Scoop, NoSQL database, and Spark, right? Yes. So going to the core structure, right? So introduction to this Hadoop and HDFS, Hadoop distributed file system, how this storage is going to happen, what are the features of that HDFS, its architecture and its storage processing, replications, configuring and fault tolerance mechanism, and MapReduce execution model, right, for processing, how it looks, and Scoop, right, for import or export operations, performing various operations while importing only if I want specific columns, specific rows to get imported, or performing some kind of filtering operations, some kind of grouping operations, merging operations, working with delimiters, transformations, right? And also during export operation. Yarn, speculative execution, speculative job, and speculative task in Hadoop. And also like versions comparisons and yarn architecture and yarn components, right? Apache Pig, right, for processing like Pig Latin language, and the important component in Hive, right? Hive architecture and loading tables, creating tables, internal and external tables, working with unstructured data, working with XML data, JSON data, URL weblog data, working with UDFs, UDAFs, UDTFs, right? User-defined functions, user-defined aggregated functions, user-defined tabular functions, non-partition and partitions, right? Multi-column partitioning, dynamic partitioning, static partitioning, performance tuning mechanism, improving the query performance, right? Bucketing in Hive, indexing in Hive, right? Yes. NoSQL database. What are the different NoSQL database? And HBase, entire in brief about this HBase NoSQL database, its architecture and its CRUD operations, and Hive and HBase integrations, the storage handlers, the other things, right? And coming to the Spark side, right? In brief about this, first I'll be discussing on Scala basics, data types, variables, right? Scala control structures, Scala collections, Scala transformations, Scala functions, expressions. And coming to the Spark core, first comparing with other technologies, right? RTD, Spark data objects, their computation steps in computation set, persistence options. What do you mean by persistence and persistence features? Various options for it. Spark core computing, fault tolerance model, different ways of creating them, increasing the number of partitions, controlling that parallelism, aggregations over structured data, groupings and aggregations, different groupings and aggregations, group by key, reduce by key, various transformations, inbuilt transformations, various actions, one by one transformations, in brief with working example, one by one, each transformations and actions, right? Now coming to the Spark SQL, right? Spark SQL programming, making data structured, performing some kind of querying on this data, right? Working with pure SQL statements, Spark can have integration, Spark with MySQL integration, working with CSV, JSON and different file formats, and deploying within the local mode, deploying within the cluster mode, right? And Spark applications, stages and tasks, driver and executor, Spark job submissions, like using creating jar files, using Eclipse IDE, using IntelliJ IDE, using build tools like SBT build tool, Maven build tool to launch Spark application, and also finally the knowledge on Spark and Cassandra, right? Fine, right? This is what I'm going to discuss. That's why I'll be spending more time on Spark, like nearly 60 hours, right? Discussion on Spark, nearly 40 to 45 hours on this Hadoop, right? So totally I'll be taking like 2.5 months for this entire course. So people can attend tomorrow also, same time, using the same link to see more on this, how exactly the data storage and processing happens within the Hadoop environment, right? So if you've got any queries related to this, right, course or this related to this, you can just go ahead with your queries. So I said the sessions will be interactive sessions. Each and everything I'll be typing and showing you. I will be demonstrating everything in a like ground level, right? The advanced level. That's why I'm taking more hours for it. So any point of time, if you've got any queries, you can just ask me. I can give multiple examples. Clear notes will be provided, and the session recording you will be getting the day itself, right? You'll be getting the recorded video of it, right? Fine. Yeah, any queries from your side? Anyone who got queries related to today's session, right? Fine. So tomorrow also you can attend the session same time using the same link to see more on this, right? Yes. So don't worry about the software, right? I'll be just providing you and demonstrate about your software. Yes, in brief, that's what I'm saying, right? In a hurry, I'm not taking like 45 hours, right? And basically you see like 45 or 50 hours for this course, but I'm taking more hours, double than that. We'll be discussing each and everything in brief, step by step. Everything I'll be typing and showing you, right? So this can be used for cloud also, right? Yes, I'll be showing you right at the end about how we can work on that. And software I'll be providing you to your Google Drives, and I will demonstrate how to use. And you can see all the Hadoop and Spark components on it. You can work with it, right? No need of any specific configuration. But if you've got good RAM, only the speed is going to differ. You will be having good speed. Fine. Okay. And before I go with the practicals, I'll be just discussing or just brushing up with the basic Linux commands, right? For understanding HDFS commands, I'll be just. Yes, Amit Patil. Yes, at the end, I'll be showing you that end-to-end explanation about this project, right? How this project flow is going. Yes. Fine. Okay. 100% understandable. You can be 100% you will be understanding each and every session, right? If anything, you can just ask me. I can give you multiple examples, right? Yes. This is Spark using Scala. Scala is that native language of Spark. Spark by default built by using Scala language, right? So I'll be just more than 2 weeks we'll be discussing on Scala programming in brief, right? Because entire coding goes in Scala. Fine. Okay. So okay, so more discussion we'll be discussing tomorrow. right? If I'm done with your queries, if there are no other queries, right? So here, yes, we are not going with yes. What is that? Amit Patel, right? So we are going to use Scala language here. Scala language. So everything I'll be discussing as part of the course. No need to write, no prerequisite. So only thing is basic Linux commands, right? Basic SQL required, but still you can understand the things, right? I'll be discussing that also before I go. I'll be explaining the statements, right? Okay. So if I'm done with your queries, right, I'll sign off for today. Meet you tomorrow. More discussion on this, right? Thank you all for your time. Thank you. Yes. Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear? Yeah, fine. So in the last class, just I was giving, right, what is big data, why Hadoop, drawbacks with the databases, Hadoop ecosystem components, right? And Hadoop and Spark job market. So today, like day by day, as data is increasing enormously, right? We need to have proper storage and processing systems to store and process the data. So we have got a Hadoop, which provides two services. It is meant for storage. It is meant for processing. So for processing, we have got Spark or MapReduce, and for storage, we have got HDFS, right? Yes. So generally, you need to know like what kind of applications we can build today by using this, going for Hadoop and Spark, right? For batch applications, right? User non-interactive applications. User non-interactive applications. Here user is nowhere required. Here user won't give any input. Okay. So everything happens in the background, right? So what are the drawbacks with the databases? Databases can store limited storage. Unlimited data storage is not possible. No parallel processing, right? Yes. Volume increases, speed decreases. Complexity increases and speed decreases here, right? Databases, the major drawback with the databases can handle only structured data, cannot handle unstructured or semi-structured kind of data, right? Yes. Okay. Hadoop follows master and slave architecture. It is not for client server. It won't follow client server architecture. It's not for request response architecture. It is not for that. So Hadoop cluster, we say, right? Hadoop cluster. Group of CPUs connected in a network. Two types of nodes we have got: master node and slave node. That is name node or data node, we say in Hadoop terminology. Master node responsibilities: assigning tasks. The task should be equally balanced to all the slaves. In the failure of any slave, task of that slave need to be assigned to any of the available slave. That process we call it as fault tolerance. Health monitoring, right? Master node will have the status about each and every slave health status, right? Slave node responsibilities for storing the data and processing the data, right? Storing and processing the data. Hadoop advantages. So here, yes, Saikat, right? So how this group of CPUs so connected in a network means, so totally how the master and slaves are connected through a network. It's a group of CPUs connected in a network. In that network we have got master and slaves. Okay, unlimited data storage in Hadoop advantages, right? Unlimited data storage because of horizontally unlimited scalability, horizontally unlimited number of slaves can be added, right? And very high speed processing because of parallel processing. Huge data in quick time, can handle all varieties of data, can handle all varieties of data, structured, unstructured, and semi-structured, right? Yes. It is an open source, no licensing required. It's a kind of cost cutting, right? So like why databases like Oracle cannot support unlimited storage? Why databases like Oracle cannot support unlimited storage, right? Databases and their max limit on the number of slaves. So what is the maximum limit on the number of slaves? Oracle can go maximum with 256 slaves. MySQL can go with 54 slaves. MySQL Express can go with 256 slaves. DB2 256. SQL Server 256 slaves. Teradata 512. No, Teradata 512 slaves. Netija also 512, Vertica also 512, but currently Teradata and Netija going with 1024 slaves. Means even though you go with 1024 slaves, right? It's not unlimited storage is not possible. Once they get filled, they cannot support data further. But there is no limit on the number of slaves that Hadoop can have, right? Hadoop can go with any number of slaves. There is no limit on this Hadoop, right? Horizontally unlimited scalability, horizontally unlimited number of slaves can be added. So if we see, right, Yahoo, when first time implemented Hadoop, it went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently it is going with 36,000 slaves, right? Yes. Facebook currently going with 36,000 slaves. Currently it is going with 36,000 slaves. So like, yes, their query asked what is the capacity of each slaves, means Hadoop can go with the commodity hardware, right? One more thing advantage you can see in Hadoop, right? Can go with commodity hardware, that is not like this configuration highly configured, those things not, right? Commodity hardware. One more advantage of Hadoop, commodity hardware means it can run on any hardware, right? It doesn't mean that you need to have highly configured systems. So here it doesn't mean that all the systems need to have equally configured. They need to have equally, that configuration should be equal. No. It can go, we can go with any whatever configuration it is. And Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, Facebook going with 36,000 slaves for storing its data, right? Processing. Yahoo. has conducted a test to check that has conducted a test by taking a table of 100 TB consisting of 1024 columns. The task is sorting based on 16 columns. Time taken by the various databases. Oracle has taken 3.5 days to process it. MySQL has taken 6 days to process it. Teradata, right? 4.5 hours. Netija has taken 3 hours. Finally, Hadoop has taken just 3.4 minutes to process it. And latest version of Hadoop has just taken 1.2 minutes, right? 1.2 minutes. Hadoop ecosystem components. Hadoop ecosystem components, right? We have got many storage and processing components for storing and processing, HDFS for storage, MapReduce for processing. It's a parallel execution model meant for processing, right? Apache Pig, it's a big Latin language, right? A simple scripting language using which we can perform the complex operations in a simpler manner. So Apache Pig Hive for processing. So totally I'll be discussing 4 processing components, mainly Spark, Hive, Pig, MapReduce for processing data warehouse, right? Second, we use like HQL, Hive query language, but my most discussion will be on the important components, right? The components which are mostly used, okay, for processing data warehouse, right? We have got a kind of language called HQL, which is similar to SQL. We'll create Hive tables here, and we have different types of tables, internal, external tables, partition, non-partition table, improving the query performance. Like we have got partitioning, static partitioning, single column partitioning, multi-column partitioning, dynamic partitioning, indexing, and bucketing, right? Yes. Scoop for import or export operation, we go for Scoop. NoSQL database, right? We have got many NoSQL database that is got schema-less behavior, random access. HBase is that we are going to discuss. Yarn, yet another resource negotiator. Zookeeper, control and coordinates the Hadoop components. Flume Kafka for advanced streaming and for messaging, right? Spark, in-memory computation, like Scala, Spark Code, Spark SQL, Spark streaming. That is what I am going to discuss, right? Yes. Now, how exactly data stored and processed in Hadoop? How exactly? Observe. How exactly data stored and processed? Observe carefully, right? In Hadoop, data is stored in the form of files. Data is stored in the form of files, right? Default block size. So each file is again, each file is again subdivided into blocks. Each file is again subdivided into blocks. Default block size, right? Yes. Default block size is 164 in the 64 MB, but in the latest version, default block size is 128 MB. Each file is again subdivided into blocks. Default block size 64 MB. In the latest versions, right? Yes. Default block size is 128 MB. Okay. For example, I got a file f1.txt file, right? The size, like, assume it's the size is like 200 MB. f1.txt, the size is 200 MB. So default block size. Default blocks, assume it is 64 MB. Into how many blocks the file is divided? f1.txt. Think this is some banking, consisting of some banking data. It's got some banking data, right? Yes. Okay, 200 MB. Default block size 64 MB. Into how many blocks it is divided? Into how many blocks? Number of blocks, right? Number of blocks equal to file size by default block size. What is the file size by default block size? That equal to 200 by 64 equal to how many? Yes, how many blocks? 200 by 64 means how many blocks? 4 blocks, right? 4 blocks. 4 blocks means B1 block. Assume B1 block. B1 64 MB. B2 block 64 MB. B3 block 64 MB. How much you got? 192. And B4 like only 8 MB it is occupying. 8 MB only. 56 MB free. 56 MB free in this. Observe here how the file is divided into blocks. f1.txt is a file of size 200 MB I am taking. Default block size 64 MB. Means the file is divided into 64, 64, 64 and 8. B1, B2, B3, B4. 64 MB, 56 MB free in this. Now I got f2.txt, f2.txt, right? Assume I got one more file. This related to telecom data, right? Yes. Some telecom data, right? Yes. Size of the file 192 MB, right? Size of the file is 192 MB. Default block size, number of blocks equal to, okay, this whole thing, right? Yes, I'm copying the same. Yes, default block size 64 MB, number of blocks equal to file size by default block size. Observe how much? 92, 192 by 64, 192 by 64. How many? Exactly 3 blocks, right? 64, 64, 64. 3 blocks exactly. Now take it like B5, B6 and B7. 64, 64, 64, right? Take it as B5, B6 and B7. Assume so B5, B6, B7. Here I got a query. Right? Why 56 MB is free? 56 MB is free in B4. Why B5 data? Why B5 data is not stored in B4? 56 MB is free in B4. Why B5 data is not stored in B4? For example, assume retrieving which one? f1.txt. Retrieving f1.txt means you're trying to retrieve f1.txt means B1 plus B2 plus B3 plus B4. B1, B2, B3, B4. B1, for example, if B5 data stored in B4, assume if B5 data stored in B4, if it is stored, then B1 is 64, B2 is what, 64, B3 also 64, B4, right, 8 MB plus 56 MB of f2.txt. That equal to totally how much? 256 MB. 256 MB. But actual file size. But actual file size of f1.txt is 200 MB. 200 MB. So 56 MB of other file data you are getting in this, right? So but actual file size is 200 MB. Wrong computation. Wrong computation, right? Yes, wrong computation. As 56 MB of other file is retrieved. If I'm trying to retrieve banking data, 56 MB of telecom data is retrieved. Wrong computation right here, wrong computation. So every file will have dedicated number of blocks. So every file will have dedicated number of blocks. Every file will have dedicated number of blocks. If I show you diagrammatically how this process happening, right? Yes. This is the master. These are the slaves, right? These are the slaves. One, two, three, four. Slave one, slave two, slave three, slave four. f1.txt equal to 200 MB. 200 by 64 equal to 4 blocks. 4 blocks means B1, B2, B3, B4. B1, B2, B3, B4. B1 stored here. B1 stored here 64 MB. B2 stored here 64 MB. B3 stored in this slave system is 64 MB. B4 only 8 MB, right? Yes. Means how this data is how this file 200 MB, right? 200 MB. How this file is distributed into blocks, how these blocks are distributed across multiple slaves and are processed parallelly, right? Think some 10 lakh records in this, 10 lakh in this, 10 lakh in this, 2 lakhs in this, right? Yes. So data is stored, distributed across multiple slaves. Data is stored across multiple slaves parallelly. Okay. Okay. So every file will have dedicated number of blocks. Every file will have dedicated number of blocks. So design principles, see, I'm just writing design principles with respect to right, HDFS blocks, design principles with respect to HDFS blocks. The first one, right, if you observe from that above example, so here I've taken a small 200 MB file. Generally, Hadoop is meant for huge data, right? Hadoop is meant for huge data. Hadoop is meant for huge data, means like GBs or TBs or data, right? In that huge data, multiple blocks you get, only the last block, the MB of size, right? So here design principles with respect to HDFS blocks means every file will have dedicated number of blocks. Every file will have dedicated number of blocks. In a single block, no two files data is stored. All the blocks have equal volumes. All the blocks have equal volume. Except the last block. Except the last block, right? Yes, design principles with respect to HDFS block. So default block size is 64 MB, but still we can configure, we can increase it to our own block size, right? See here, default block size is 64 MB, but we can set to 100 MB, 150 MB, we can configure, we can custom block size, we can have our own block size also. By default it is okay. How exactly data storage and processing is happening? How exactly data storage and processing happens? How exactly data storage and processing happening within this, right? So if I talk, I'm going to discuss 4 cases here. Observe. Case 1, if number of blocks, number of slaves, if number of blocks means, think that 4 blocks equal to 4 slaves, then full parallelism, right? Full parallelism, high speed. For example, to show you this, I've taken a file f1.txt, the size around like 230 MB. Number of blocks, how many? Number of blocks, 230 by 64. Means 230 is the file size, 64 is the default block size. By default, what is the size? Okay, 230 by 64. How many blocks? 4 blocks, right? How these 4 blocks are stored across the 4 slaves? This is the master node. These are the slave nodes. Slave 1, slave 2, slave 3, and slave 4. Number of blocks, how many blocks you got? 4 blocks, right? How many blocks? 4 blocks. B1, B2, B3, B4. B1, how this data is divided into 4 blocks. In Hadoop, always data stored in the form of files, files divided into blocks. Yes, think B1 10 lakh records, in B2 10 lakh records, in B3 10 lakh records, in B4 also some 8 lakh records, right? Yes. B1 is stored here, B1 is stored here, B2 here, B3 here, B4 here, right? Yes. Here 10 lakh records, here also like 10 lakh records, here also like 10 lakh records, here like 8 lakh records, right? Here, this is the master node or name node, we say name node stores metadata, stores metadata. Metadata means what? Data about data, data about data. So here f1.txt, what is the work of name node? The file f1.txt into how many blocks? B1, B2, B3, B4. B1 stored in S1, B2 in S2, B3 in S3, B4 in S4. This is how exactly data storage happens. How exactly the data storage happens, right? Yes. So here, if you talk about in Hadoop, data is stored in the form of file f1.txt. If you take the file, whatever the file size, MBs or GBs, right? It is divided into blocks. What is the file size? 230. Default block size, each block of how much, what is the size? 64. Means how many blocks? 4 blocks. B1, B2, B3, B4. Think some records, 10 lakh records present in each block. How these blocks are distributed? Master and slave. Multiple slaves, multiple blocks are stored across multiple slaves. And name nodes maintains the metadata information. Data about data. It maintains data about data. And the data nodes or slave node stores the actual data, and this master node or the name node stores the metadata, right? Now how this is storage happening? How this storage, right? Data storage. Now data processing. How this processing, right? Data processing. This is case 1. I'm going to show you like 3 cases here, right? Job, what is your job? To process f1.txt file. Always in Hadoop, the job is divided into tasks, then only parallel processing can be achieved. For example, if you take a labor example, for a constructional work, a job, if you divide into, you have got some 10 labors. Instead of giving the work to a single labor, if you divide it into tasks and if you assign to multiple labors, slaves, right? You can get more speed, right? You can see more speed. Here also, job always in Hadoop, job always divides into tasks. Number of tasks into how many tasks. In Hadoop, the number of tasks always depends on number of unique blocks. Number of unique blocks. Yes, how many unique blocks here? How many unique blocks? I want the sessions to be interactive. How many blocks here? 4, right? Here, 4 blocks. All 4 are unique blocks. No duplicated blocks means how many tasks? 4 blocks means 4 tasks, right? T1 task, T2 task, T3 task, T4 task. So here my job to process f1.txt into how many tasks it is divided? T1, T2, T3, T4. Why 4 tasks? Why 4 tasks means T1 task is for executing for which one? For 4 blocks, 4 tasks. For executing 4 blocks, you got 4 tasks. For 10 blocks, 10 tasks you get. For executing, right? B1, 10 lakh records. T2 is for executing B2, 10 lakh records. T3 task is for B3, 10 lakh records. And T4 task is for executing block 4, 8 lakh records, right? Here, understood. 4 tasks. Now try to answer, right? You can unmute yourself and just give your responses through voice, whether your answers are correct or not. Not a problem, right? Here, T1. Who should execute the T1 task? who should execute the T1 task means P1 10 lakh records. Means which slave need to execute it. Which slave need to execute T1 task, B1 10 lakh records. S1 only, right? There is no other choice. Slave 1 only. Who should execute to T2 means? T2 means for executing B2. B2 present in slave 2. Slave 2 only can execute, right? T3 means task 3 is for executing B3, block B3, 10 lakh records. So who should execute it? Slave 3 only. As B3 block is present in slave 3 only need to execute that. Slave 3 only can execute it. No, okay. T4. Okay, slave 4, right? Yes. So here for executing 4 tasks, who should execute T1 task? T1 should be executed by slave 1. T2 by whom? Slave 2. T3 by whom? Slave 3. T4 by whom? Slave 4, right? Yes. 4 tasks executed by 4 slaves parallelly. So here all these 4 slaves executes 4 slaves S1, S2, S3, S4. 4 slaves are executing 4 tasks. Four slaves S1, S2, S4 slaves are executing 4 tasks. 4 slaves are executing 4 tasks. T1, T2, T3, T4 parallelly. No, see here, all the tasks are executed parallelly, right? No task is in the waiting state. So full parallelism here. So I was said if we got number of blocks equal to number of slaves, blocks 4 only, slaves also 4. Full parallelism, high speed. No task is in the waiting state. 4 slaves executing 4 slaves. Sorry, 4 slaves executing 4 tasks parallelly. High speed, right? You can see high speed in this. See, this is what processing happens, right? How storage is happening and how the processing happening, right? Now see that case 2, right? Case 2, example 2. How this storage happening? File divided into blocks. The blocks distributed across these slave machines, and job is to process f1.txt divided into task. Task nothing but number of unique blocks. How many? 4 means 4 tasks. T1 task for executing V1 block, T2 for executing V2, T3 for B3, T4 for B4. 4 slaves executing 4 tasks pattern. Now observe this case 2, right? Number of blocks. Number of blocks more than number of slaves. I got 4 blocks, only 2 slaves. Less parallelism. We will see less speed. Just like if you take a labor example, 4 tasks are there, only 2 labors available. 2 labors doing 2 tasks. Remaining 2 tasks will be ideal, right? Will be in the waiting state. So here, if I talk f1.txt, 230 MB size is what? 230 MB size. Into how many blocks? Default block size. Each block will be divided into 64 MB blocks. into how many blocks the file is divided. 230 by defaultly 64 MB is the block size, into 4 blocks, right? Into 4 blocks. 4 blocks B1, B2, B3, B4. How these 4 blocks are stored across the slaves, right? Yes, this is master. Only 2 slaves this time. This time not 4 slaves, only 2 slaves. Slaves are less. Slave 1, slave 2. Yes. Slave 1 and slave 2, right? Yes. So this is a name node. This is what? Name node, right? Stores metadata. Metadata, right? It stores metadata, means data about data. Stores metadata information, data about data, right? Yes. So here, where how these 4 blocks are distributed across the slaves. B1 here, B1 here, B2 here, B3, B4. Okay, here f1.txt, name node maintains the details, f1.txt, right? B1, B2, B3, B4. Okay, B1, B2, B3, B4. Like f1.txt divided into 4 blocks, B1, B2, B3, B4, where B1 stored? S1, B2 in S2, B3 again S1, B4 in slave 2, right? This how data and the blocks are distributed. For example, if you got 10 blocks, only 2 slaves, assume 5 blocks in one slave, 5 blocks in another slave. Here 4, 2 slaves, 2 in one, 2 in another, right? Yes. Okay. This is data storage, right? This is data storage. This is case 2 I'm discussing. Now data processing, if you go data processing, take like job is to process f1.txt. Always job divides into task, number of tasks in Hadoop. Always the number of tasks equal to number of unique blocks. Number of unique blocks. How many unique blocks here? 4, right? 4 blocks. All are unique. B1, B2, B3. There are no duplicated blocks. B1, B2, B2, B2 like that. 4 blocks. 4 blocks means how many tasks? 4 tasks. T1, T2, T3, T4. Okay. Job is like processing f1.txt divided into how many tasks? T1, T2, T3, T4. T4, T1 for executing. T1 is always for executing B1 block. T2 for executing B2 block. T3 for executing B3. T4 for executing B4, right? Yes. Who should execute this T1 task? Who should execute this T1 task? Try to answer. Who should execute this T1 task? Everyone, try to answer. S1, right? There is no other choice. No other choice, right? Only S1 only should execute. Who should execute to T2 task? S2 only. There is no other choice. T3. T3 by S1. T3 by S, T4 by again S2. Here, if you observe carefully, right? Yes. T1 and T3 task to this, T2 and T4 task to this. If you observe slave 1, if you take slave 1, if you take slave 2, slave 1 should execute T1 comma T3. Slave 2 should execute T2 comma T4. When T1 is executing, here T2 will be executing. That's fine. But T3 will be in the waiting state here. Here T4 will be in the waiting state when T2 is executing. Once T1 execution finished, now it will just execute to T3. Once T2 execution finished, next it will execute T4. Means here some tasks are in the, here some tasks are in the waiting state, or in waiting state. Some tasks are in the waiting state, right? Yes. Means here T1, T2 only executing parallelly. T3, T4 are in the waiting state. Means it takes more time, right? Previously, all the 4 tasks executed parallelly, taking 1 hour, assume. T1, T2, T3, T4 takes, each task take 1 hour to complete. All the 4 tasks complete in 1 hour only. But here T1, T2 takes 1 hour, T3, T4 takes 1 hour. 2 hours it takes. Here some tasks are in the waiting state, less speed it takes, less speed, more time. Okay, fine. That is case 2, right? Yes. Case 3, if you observe this case 3, only one slave. If you observe this case 3, more blocks, one slave. B1, B2, B3, B4. Only one slave S1, right? Assume this is my master. This is my slave. Only one slave. In this one only B1 stored, B2 stored, B3 stored, B4 stored. This name node stores that f1.txt divided into 4 blocks, B1, B2, B3, B4. How this is means, you got f1.txt into size 200 MB, number of blocks 200 by 64, file size by default block size. Like how many blocks? 4 blocks you get. 4 blocks means B1, B2, B3, B4, B2, B3, B4, right? This is how storage happens. B1 by S1 only, B2 by S1 only, B3 by S1 only, B4 by S1 only. Data processing, right? Job f1.txt into number of tasks, number of unique blocks. How many blocks here? 4 blocks, right? T1, T2, T3, T4. So here job to process f1.txt into how many tasks? T1, T2, T3, T4. This for executing what? B1, T2, B2. T3 by B3, T4 by B4. It seems like you got 4 tasks. If you take a labor example, a constructional work, 4 tasks are there, but only one labor, one slave is there. That slave only need to perform all the 4 tasks, one after the other sequentially. Here also same. Who should execute a T1, right? Who should execute a T1? There is only one slave S1. There is no other choice, right? T1 by is slave 1 only. T2, T2, slave 1 only. T3, slave 1. T4, slave 1 means here all the 4 tasks are executed by slave 1 by slave 1 sequentially. Here no parallel processing, right? Yes. So here what is your observation? More slaves, more speed. Less slaves, less speed. If only one slave, no parallel processing at all, right? Yes. Okay. Here only one slave means no parallel processing, no less speed, sequential processing happens, right? Here I got a query, right? Try to answer this. In the case one, number of blocks 4, number of slaves 4, means 4 tasks. These 4 tasks are executed by 4 slaves parallelly. Think that if you take a bigger file of TVs, like you got like 70 blocks, 70 tasks stored across 70 slaves. As these 4 tasks are executed by 4 slaves, suddenly if any one slave goes down, as they are machines, if any one slave goes down, each slave storing 10 lakh records, right? Means this 10 lakh records gone, right? If the data is very sensitive data like banking data, 10 lakh records lost, huge data loss. So how Hadoop is able to overcome this kind of situation, right? So one is the data will be lost, 10 lakh. One is the task T2 will be failed. If T2 failed, the job also will be failed, right? How Hadoop is able to overcome this kind of situation? So there is a concept for this replication and fault tolerance in Hadoop. Okay, that we'll discuss the tomorrow session, right? So any queries you have got, anyone as part of today's session? Just I was saying you. So again, in brief, I'll be discussing, right, how that storage architectural components, processing architectural components, Hadoop architecture. Still I didn't discuss. So this is the course content, right? Big data, Hadoop and Spark. Introduction, HDFS, MapReduce, SQL, scoop, right? Scoop with multiple imports. Nearly I'll show you 30 imports in scoop. Import operations, yarn, Apache Pig, and important component like Hive, Apache Hive, right? In brief, in depth. NoSQL database, Spark with Scala, Scala programming, Scala control structures, Scala collections, Scala transformations, Scala functions, direction to Spark, computations, persistence options, Spark core computing, groupings, aggregations, various actions and transformations, Spark SQL and deployment modes in cluster, and okay, Spark applications and Spark submission, right? Yes. So this is what I will be discussing. Any queries you have got, anyone? Fine. So I'll show you the data pipeline, right? Yes, I'll be showing you the data pipeline. So just only for the first 2-3 days, like you will be having 3-4 days, you'll be having, okay, But once we enter into the practical, there won't be any theoretical, right? Means everything step by step I'll be explaining you, right, how this process goes. Yes. So tomorrow also, if people can attend the session, same time at 7 p.m. using the same link to see more on this. Fine. Yes. So if I'm done with this, I'll sign off for now. Meet you tomorrow, same time, same link. Yes. Thank you all for your time. Thank you. You can see this payment process and procedure, right? This in the chart panel. Fine. Tomorrow also it will be pasted in this chat. Fine. The course content is forwarded. If we observe this chart panel, right? The chart demo link is provided in that course content. Demo videos are given in that demo videos and course content. The fee structure, right? Yes. So if okay, if anyone done with that, okay, payment, right? You need to give that screenshot of that payment to Durgasoft online trading at the rate gmail.com. Observe this at the last, you can see it. Sending your screenshot to Durgasoft online trading at the rate gmail. Okay, fine. I'm stopping. We'll continue tomorrow. Fine. Okay. So I got a file f1.txt of size 192 MB, number of blocks 192, right, by 64, right, 3 blocks, B1, B2, B3, B1, B2 by 10 lakhs, B3 by 10 lakhs, right? Yes. B1, B2, B3, right? Yes. How these 3 blocks are going to get distributed across multiple slaves, right? I got to assume that I got slaves in this way. I got slaves like this, right? Slave 1, slave 2, and slave 3. Slave 1, 2, and 3, right? Yes. In slave 1, B1 is stored. In slave 2, B2 is stored. In slave 3, B3 is stored, right? Yes. B1, B2, B3. In B1, 10 lakh records. B1, 10 lakh records. B2, 10 lakh records. B3, 10 lakh records, right? So this is the master node we call name node, right? Name node stores the metadata information, data about data, right? It won't store the data. Actual data is stored by the data node, slave nodes. Metadata is stored by this name node. Means, for example, a file divided into blocks B1, B2, and B3. B1 block, B2 block, and B3 block. B1 stored in S1, B2 in S2, B3 in S3. B1 in S1, B2 in S2, and B3 in S3. This how this data is getting stored, how these blocks, how the file divided into blocks, how these blocks getting distributed, stored across multiple slaves. Tomorrow, if you want to retrieve, right, name node, if it wants to retrieve this f1.txt, should combine the memory location addresses of this B1, B2, B3 stored in S1, S2, S3. Fine. Data processing. How this data processing, right? Yes. To execute, for example, job is to process f1.txt, right? Into job divided into tasks. In Hadoop, always the number of tasks. So here, file divided into fixed size blocks of 64 MB, or if you give 128, or if you give your own custom size, the blocks will be taking that default block size, going to be distributed across multiple slaves and processed by multiple systems parallelly, right? And the job is divided into tasks. In Hadoop, always the number of tasks depends on number of unique blocks. Number of tasks equal to number of unique blocks means how many blocks here? 3 blocks, right? 3 blocks. 3 blocks. 3 blocks means 3 tasks, right? 3 tasks. 3 tasks. T1, T2, T3. T1, T2, and T3. So job to process f1.txt into how many tasks? T1, T2, and T3. So if you want parallel processing, right, job to be divided into tasks, the tasks need to be assigned to multiple. T1 for executing, right? T1 for executing B1. T2 for executing a B2. T3 for executing B3. B1 10 lakh records. T2 for executing B2 10 lakh records. T3 for executing B3 10 lakh records. Okay. Now try to say who should execute this T1 task? Yes. Who should execute this T1 task? Means B1 block execution. Slave 1 only, right? No other choice. T2 by S2 only. T3 by S3 only, right? So 3 tasks. 3 tasks. T1, T2, T3 are executed parallelly. By 3 slaves. S1, S2, S3 parallelly. So there is no task is in the waiting state. Understood, right? If you take any file, how this file divide into blocks, default block size 64 MB into blocks you are getting. The blocks are getting stored across the slaves B1, B2, B3. Name node stores the metadata information, and processing the file. The job is divided into tasks. How many tasks? Number of unique blocks, right? Number of how many unique blocks here? 3 blocks only. All are unique, right? So 3 tasks. T1 task for executing B1, T2 is for executing B2, T3 is for executing B3. So who should execute these tasks? T1 task S1 only, right? See, T1 task S1, T1 task will be assigned to slave 1, T2 task to S2, T3 to S3. So here I said if more slaves, right, more speed. If less slaves, less speed. If only one slave, no parallel processing at all. No parallel processing at all, right? Yes. Okay, understanding, right? Yes. Now, these three tasks are executed by the three slaves parallelly. Okay, think that if you take a bigger file, more tasks you will get. More tasks are executed by multiple slaves parallelly, as these are machines, right? Slaves are machines. Suddenly, if multiple tasks, if three tasks are executed by three slaves parallelly, suddenly, if any one slave goes down, then two things you can observe, two drawbacks you can observe, right? One is data loss, 10 lakh records lost. Second one is this task T2 got failed. Task T2 failed means job also failed. So data loss, job failure. How Hadoop is going to overcome this kind of situation, right? Means how the data loss and this task failure means there is a concept called replication and fault tolerance, right? Now today my discussion like replication, fault tolerance. Okay. Replication and fault tolerance, right? Yes. Replication and fault tolerance. Replication, like it's like replication, it's like duplication, right? Default number of replications, replications we call replicas. 3 by default, 3 replications. Default number of replications or replicas 3. Okay, default it is 3, but if you want to configure, if you want more replicas or replications, you can increase or decrease the replications. We can configure the replications, right? I'll discuss how to configure, increase or decrease the replications. Means duplication or replication is for the file or for the blocks. Understand here, these replications are for the file or for the blocks. Okay, observe this example to understand this entire replication and fault tolerance mechanism, fault tolerance model in Spark, sorry, in Hadoop and Spark, right? So later I discuss about Spark, but f1.txt, think it has got 192 MB, the block, the size of this file 192 MB. So this file divided into blocks. Any file in Hadoop divided into blocks. Number of blocks. How many blocks? The size, whatever the size, by how many pixel size blocks. The size of each block, it is 64 MB or 128, depending upon that, it will be divided into blocks. Here 3 blocks, 64, 64, 64, exactly 192, right? 3 blocks. 3 blocks means B1, B2, B3. Assume B1 block, B2 block, B3 block. Now replication, right? Replication. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times. Totally 9 blocks. B1 by 3, B2 by 3, B3 by 3, right? 9 blocks. How these 9 blocks are going to get distributed across these slaves, right? Assume these are the slaves, right? S1, S2, S3. In S1, how 9 blocks need to be stored? B1 here, B2, B3, B1, B3, B2, B3, B1, B2. So 9 blocks stored across these 3 slaves, right? Yes. This is the name node, stores metadata information. All right. F1.txt, yes, divided into 3 blocks, B1, B2, B3. B1 stored in S1 it is stored, in S2 also it is stored, in S3 also it is stored. B2 is stored in S1, in S2 and also in S3. B3 also in S1, in S2 and S3. In the previous example,